Okay, let us start today's session. In this, we will start the new topic, new unit, that is unit number 2, bonding in solids and X-ray diffraction. And since it is the first period of the unit, we will see the introductory part and one type of bond, that is ionic bond. So introductory part includes interatomic forces and types of bondings, types of bonds, and then we'll see the very first type of bond, basic type of bond, fundamental type of bond, that is ionic bond. So let us see first of all the interatomic forces and types of bonds, types of bondings. So what are bonds? We find that solids, especially crystalline solids, have specific shape, and that is because there are specific type of forces that exist between the atoms, and these forces binds the atoms of the crystal together. The forces which bind the atoms of the crystal or atoms of the solid together, those are called as bonds. And these bonds are basically or by origin electrostatic in nature, and depending upon the electrostatic interaction between the two atoms, these bonds are classified into different classes. Okay, so the crystals are again classified into or categorized into different categories depending upon the bond that exists between the two atoms of the crystals. Okay, so especially the interatomic forces that exist between the two atoms to holds the atoms together. Now, the interatomic forces that hold the atoms together are the electrostatic forces of attraction. Does it mean that there does not exist a repulsive force between the atoms? The example is the property of the solids, that if we compress a certain solid, a large external force is required to compress the solid. Unless and until the large external force is applied to the solid, it will not get compressed. What does it mean? It means there exists a repulsive force also between the atoms. In this way, there are two types of intraatomic forces exist, and those are, very first one is the attractive force that binds the two atoms together. Okay, and the attraction is the type of Coulombian type of electrostatic attraction that exists between the number of electrons in the atoms, what we call as the electron cloud of the atom, with the positive charge of the nucleus of the atom. In nucleus, we have protons and neutrons. Neutrons doesn't carry any charge, while protons has positive charge. So nucleus of the atom has positive charge. So between the nuclear positive charge of the nucleus and the electron cloud, which is negative because electrons are negatively charged. So the force of attraction exists between negatively charged electron cloud of one atom and the positive nuclear charge of the other atom. This force is attractive type of force, and this produces the bond. There exists a repulsive force. The repulsive force exists when the two atoms came so close to each other that the electron clouds of the atoms overlap on each other. And since these electron clouds are of negative charge, they there exists a repulsive force between the identical charges, that means these negative charges of the electron clouds, and hence there is a repulsive type of force also exists. The repulsive does not only exist between the electron clouds, but it exists between the two positive nuclei of the two different atoms. Okay, that means there are the repulsive, the contribution to repulsive forces. There are two types of contribution to the repulsive forces and between the atoms, and that is due to positive nuclear charges, and another is due to the what you say negative charges of the what you say electron clouds of the two atoms. Okay. Now let us look at the different criterias those are responsible for formation of the bond. Okay, it is the charge distribution between the valence electron that decides the criteria of the bond formation. Okay, valence electrons are the electron those exist in the outermost orbit of the electron, and it has been observed that these electrons, okay, decide the criteria behind the formation of bond. Okay, as you can see in this slide, there are five types of criteria. Very first one is transfer of electron. That means valence electron from one atom transfer to the other atom. Okay, when such type of criteria took place, the atoms no longer remain atoms, but they become ion. Okay, one is positive ion, other is negative ion, and there exists a bond between the ions, and that is called as ionic bond. The best example of ionic bond is NaCl. Okay, the bond that exists between Na plus crystal, Na plus atom, Na plus ion, and Cl minus ion. The next type of criteria is the sharing of electrons. When the two atoms came so close, then that they share an electron or number of electrons between the common space in between them, and this gives rise to formation of a bond between the two atoms, and such type of bond is called as covalent bond. Best example is a diamond material. Diamond material is the hardest possible material on the earth. Okay, implying the strength of the bond that is formed due to sharing of electron, that is the covalent bond. The next criteria is existence of free electrons. It has been observed that in few crystals, especially in metals, the valence electron does not belong to a particular atom, but these valence electrons move freely inside the metal or inside the crystal, metallic solid. Okay, inside the metallic crystal, these electrons move freely and they behave as if they are the free electrons. Okay, and they keep the all atoms, they produce the bonding between the atoms, and such type of bond is called as metallic bond. And the examples are the different metals like copper, silver, etc. etc. The next criteria is induction of a dipole or dipole induced bond. The dipole is induced especially when an atom has a large number of electrons. The best example are the oxygen, nitrogen, or the what do you say, the noble gas atoms or inert gas atoms. They have large number of electrons, and the electron cloud of their electron cloud has large number of atoms, and when this electron cloud, which is spherically distributed from all sides, is disturbed due to certain any kind of force, then the charge distribution took place. That means negative charge come to one side, while on the other side there are very less number of electrons. So it becomes a dipole. That means the positive and negative charge separated by a distance. Okay, and such type of bonds which are weaker bonds, those are called as van der Waals forces. And the best example, as I have told to you, the solid oxygen, solid nitrogen, and solid different inert gas, solids of different inert gases. Okay, and The last criteria is due to a specific nature of the atom, and this specific nature of the atom is the single electron and single proton, and only one example of such type of element is the hydrogen atom. The hydrogen atom has only one electron in its orbit and only one proton in its nuclei. So due to which the very strong bond is formed between the hydrogen atom and the highly electronegative atoms like chlorine, fluorine, oxygen, etc., etc. So the hydrogen bond that has been formed, and the best example is the solid form of the water, and that is ice. Okay. So out of these five bonds, the first three bonds, that is ionic bond, covalent bond, and metallic bond, these are called as primary bonds, while the last two bonds, that is van der Waals bond and hydrogen bond, are called as the secondary bonds. Okay, depending upon the bond that has been possessed by the solid, the crystals or solids are categorized, but this categorization depending upon the bond that has been obeyed by the atoms, exists between the atoms, is quite arbitrary, because there are different solids, large number of solids which exist, in which there exist different types of bonds, that means more than a single type of bond there are. Okay, the best example is the another type of carbon crystal, that is a graphite. Graphite we use in a pencil. Okay, now the graphite crystal, in graphite crystal we found that the at the crystal, the layers, the atoms are arranged in the different layers, and if you are looking at the bond between the atoms of a layer, it is a covalent bond. Okay, second type of bond. On the other hand, if you are looking at the bond between the atoms of the nearest layers, okay, the nearby layers, it is the weakest bond, and that is the van der Waals bond. Okay, so this is in this way we cannot categorization of the crystals or solids into different categories according to the bond that exists between the two atoms. It is quite arbitrary, but it is made always. And ionic bond, the crystal or solid that possess ionic bond is called as ionic crystal. For example, NaCl is an ionic crystal, while the the solid that possess the covalent bond is called as covalent crystal. Accordingly, the metals, the metallic bond, the atoms, if metallic bond exists between the atoms, it is called as metallic crystal. Okay, so in this way, different categories exist. So it was about the introduction, and let us move towards the very first and very basic fundamental bond, that is ionic bond. Now, as I have told to you, the ionic bond is formed due to the transfer of electron from one atom to another atom. Now, question is, what happens when the transfer of electron took place from one atom to other atom in a solid? In that case, both the atoms, the atom that from which the electron is transferred and the atom to which electron is transferred, both acquire a stable electronic configuration. And which are the atoms in the periodic table which has stable electronic configuration? These are the atoms of atoms of noble gases or inert gases. Okay, argon, krypton, xenon, radon, neon, etc., etc. Okay, so in this way we can define, if it is told to define the what is ionic bond in a single sentence, we can define like the bond formed by the actual transfer of electrons from one atom to the other, so that the acquire atoms acquire stable electronic configuration, okay, equivalent to the nearest inert gas atom. Okay, so such type of bond is called as ionic bond. So ionic bond that produced due to transfer of electron, by the way the atoms acquire a stable electronic configuration equivalent to their nearest inert gas atom. Such type of bonds are called as ionic bond, and the crystals are called as ionic crystals. Okay. Now, what happens here is that due to the transfer of electron, one atom loses its electron while other atom accepts the electron, okay, or gains the electron. The atom which loses the electron, it has the less negative charge, so therefore it is called as electropositive atom, and it becomes electropositive, rather we can say, and the electron which accepts the electron, that becomes, that has excess of, that is rich in electron, rich in negative charge, and it is called as electronegative. So atom which loses electron, that becomes electropositive, while the atom which accepts electron, that becomes electronegative. Okay. The ions, the ions now, after transfer of electron, the atom never remains atoms, okay, because they acquire the charges. Okay, the atom which loses the electron, that becomes positive, that becomes positive ion, while the atom which accepts the electron, that becomes negative ion. Okay, these ions, the bond is formed between these ions, and that bond is called as ionic bond, and crystal is called as ionic crystal. Okay, so the ions in the crystal, how they arrange themselves? The ions in the crystal arrange themselves according to, in the such a way that the Coulomb's attractive force between the positive and negative charge, that means Coulomb's attractive force between the oppositely charged ions is greater than the repulsive Coulomb's repulsive force between the charges of the same sign. That means charges, the Coulomb's repulsive force between the negative ions and Coulomb's repulsive force between the positive ions. Okay, so this repulsive force, the repulsive force is totally dominated by the Coulomb's force of attraction, or Coulomb's attractive force. Okay, that means Coulomb's attractive force is so large that it totally dominates the repulsive force, and it is the attraction that exists, and the bond is formed, and the crystal is formed. Okay, thus the Coulomb's electrostatic interaction. Okay, that means the attractive force between the positive and negative ions, and the repulsive force between the positive and negative ions is the criterion behind the formation of the bond. So the ionic bond is originated due to the Coulomb's electrostatic force of attraction between a positive ion and negative ion, and the ions are formed due to transfer of electron. And why transfer of electron took place? Because due to transfer of electrons, the atoms complete their octets and they become stable, equivalent to the inert gas atom. Okay, now let us move further, uh, and let us look at the coordination number. We have find that the uh, crystals, the ions in the crystal arrange themselves such that the attractive force dominates the attractive force between the opposite charges dominates the attractive force between the identical repulsive force between the identical charges. Okay, now what will be the coordination number? It has been observed that the criteria behind the coordination number, that the, that is the, what do you say, decided by the since after the transfer of electron, ions acquire the electronic configuration similar to the inert gas atom, the charge distribution of the atom ions is spherically symmetric. Now, what happens is that when transfer of electron took place, okay, both the atoms become stable. Okay, their electronic configuration is stable because their octet is completed, and their electronic configuration becomes equivalent to the nearest inert gas atom. And what happens is that in inert gas atom, the distribution, charge distribution, that means charges of the electron are symmetrically distributed. Okay, so that's why the attraction between the two inert gas atoms is not possible. So same thing. So what happens here is that the negative charge of the, or the charges of the positive and negative charges are spherically symmetric. That means attraction between the opposite ions and repulsion between the opposite ions is possible between from all the sides. And as attraction dominates the repulsion, the ion one ion tries to have as many neighbors as opposite type as possible, because it is the attraction, Coulomb's attraction, electrostatic attraction, that is possible between the two positive or the two opposite ions, one positive and one negative and one positive. Hence, ion of one type, one kind, that means either positive or negative, tries to have as many neighbors of opposite charges as possible. Okay. Now, there are two criteria in deciding the coordination number. The coordination number is limited. Coordination number of the cation. The cation means what? The ion that has positive charge, that is called as cation. So the ion with positive charge, that is cation, has the coordination number that is limited by the radius ratio. That means radius of cation to radius of anion. So this ratio of radii of cation to anion, that limits. Okay, that decides the number of neighbors or number of coordination number, the coordination number of the cation. On the other hand, the number of cations, okay, that surround the anions, that means number of anions, the coordination number of the anion is limited by the charge neutrality of the crystal. Okay, because overall there is no charge on the crystal, so number of cations is equal to number of anions. So that charge neutrality condition is puts the limit on the coordination number of the anion, while coordination number of the cation is limited by the ratio of cation, radii of cation to anion. Okay. Now, what about the cohesive energy? Now, what is the cohesive energy? The energy released during formation of the bond, that is called as cohesive energy. Okay, and it has been observed that more the energy released, more will be the more the strong will be the bond. Okay, in case of what we call in case of the ionic crystal, the cohesive energy is so large that it resides between the range of 5 to 10 electron volts. That means the cohesive ionic crystals are the ionic crystals are stronger. The cohesive energy of the ionic crystal is large, and it lies between 5 to 10 electron volts. So ionic crystals are, what do you say, stronger crystals. Okay. Now, let us look at the example of the ionic crystal. As I have told to you, the best example of ionic crystal is the NaCl. Now, how bond is formed in the NaCl crystal? That Okay, the bond formation can be understood from the electron configurations of the atoms. Okay, that took place that took place take in the formation of the NaCl crystal. Take part in the formation of the NaCl crystal, and those are Na atom and Cl atom. Okay, the electron configuration of the Na atom is 1s2, 2s2, 2p6, 3s1. That means 2 plus 2, 4 plus 6, 10 plus 1, 11. There are 11 electrons. Okay. While the last orbit is 3s, in which there is only one electron. Now, what about the chlorine? It is 1s2, 2s2, 2p6, 3s2, 3p5. That means the last orbit is 3p and it has 5 electrons. Okay, electrons. Now, what happens? What criteria is possible here? Okay, the Na atom has only a single what do you say, a single electron in its last orbit, so it can easily lose the electron, and it has a lag of only one electron. Chlorine has a lack of only one electron, so it can easily accept the electron. So electron transfers from the 3s orbit of Na. One electron transfers from 3s orbit of Na to the 3p orbit of, what you say, chlorine, and so that the electron transfer takes place, and the atoms becomes ions, and their electronic configuration becomes like this. That Na plus is now 1s2 plus 2. Since it has lost one electron, it becomes positive ion. And what about the chlorine atom? It has acquired one electron, gain one electron. So it becomes a negative ion. The electronic configuration of the Na plus is equivalent to Ne, that is neon, and Cl minus is equivalent to argon, Ar. Okay. Now, what about the coordination number? As I have told to you, the coordination number of the cation, that means positive ion. So in this case, it is Na plus. Okay, is limited by the radius ratio of cation to anion, and in this case, the radius ratio of Na plus, radius of Na plus to Cl minus ion. Okay, supports to the six neighbors. So Na plus has six Cl minus neighbors according what you say radius ratio rule. While Cl minus, the number of neighbors of Cl minus is decided by charge neutrality. In order to make the charge neutrality, the Cl minus is surrounded by six Na plus. Okay, so in this way, in all, positive and negative ion, each ion has the coordination number that is equal to six. Now, let us move to the structure of NaCl crystals. Okay. Now, it has been observed that each Na plus Cl minus, and Cl minus has six Na plus. What is the that if
आलं की काय सांगायचं
for example, say Na plus crystal. Now, how many neighbors are there? Okay, so one, two, three, four. In this plane, there are four neighbors. While this is fifth one and this is sixth one. Okay, so in this way, there are six neighbor to Na plus. Similarly, you can find that the Cl minus has six Na plus neighbors. Okay, now what is this is the unit cell of the NaCl crystal, and what is the structure of the unit cell? Okay, in this case, you will find that four Cl minus occupy four FCC positions. So, what are the FCC positions? So, these are the FCC positions. Okay, so four Cl minus atoms occupy the FCC position. So, these are the FCC positions. Okay, one, two, three, four. Okay, while uh, the octahedral white positions are occupied by the Na plus, 4 Na plus ions. So these are 1, 2, 3, 4 octahedral white position. So these are occupied by Na plus ions. Okay. Now, what important thing is that if you are looking at the next layer, you will find that these octahedral white positions of the sodium ions are interchanged by the chlorine ions. Okay, you will find here. And the FCC positions of Cl minus ions are now replaced by the sodium ions. That means the FCC and octahedral positions are interchangeable. Okay, so in this way, you will find that NaCl crystal, NaCl structure is consisting of two FCC lattices, one of Na plus and other is of Cl minus. These are interpenetrating in each other. Okay, you can observe by the careful observation. Now, what about the basis? The basis of the NaCl crystal consisting of two ions. Okay, one Cl minus and one Na plus. Okay, so and the unit cell consisting of four molecules. So this totally is repeated. We have seen in the special crystal structures in the previous chapter. Now, interesting is to look at the arrangement of ions. You will find that Na minus ions are at the corners of the unit cell, while Na plus are at the octahedral wide positions. Okay, so it is interesting to note the comparable sizes of the Cl minus and Na plus, okay, ions. Cl minus ions has very large size as compared to Na plus, and these are arranged in such a way that okay, the Cl minus are at the corners and Na plus as at the what do you say? Na plus occupies the space between the two Cl minus ions, two Cl minus ions, two Cl. Okay, so in this way. Okay, now look at the properties. See, cohesive energy of the ionic crystal is between 5 to 10 electron volts. So these are the very strong crystals. So these crystals are hard. Okay, hard, that means their strength is very high. Okay. So since possess large cohesive energy, they possess high melting and boiling points. Okay. Since the atoms are tight, the ions are tightly bounded. Okay, the electricity will not flow through them, so they are poor conductors of electricity. Okay, but if the temperature increases, the conductivity increases with temperature. Why? That is due to increase the mobility of the ions. Okay, so ions which are fixed at their position become mobile with the increasing temperature, and the ions, they have specific charges, so therefore they can contribute to the conduction of electricity, and conductivity increases with the temperature. Okay. Now, another property is that the crystals, ionic crystals are transparent to the visible light. For example, to the sunlight, they are transparent. But if we use invisible light, for example, infrared light, they gives the characteristic absorption spectra. So you can recognize whether it is NaCl or CaCl, cesium chloride, by taking the IR absorption spectra, because IR absorption spectra is the characteristic spectra of the specific ionic crystal. The ionic crystals are soluble in polar solvents, and best example of polar solvent is the water. Okay, so the negative and positive poles are there in the polar solvent. The water molecule has negative charge towards one side and positive charge towards another side, and therefore these are called as polar solvents. And the ionic crystals also possess negative and positive charges, so therefore they are soluble in polar solvents. Okay, and here the topic is open for the question. If I will unmute.